Hello, welcome to the lecture series on solar power generation. In this lecture video, we are going to discuss battery charging techniques, or we are going to have a detailed understanding that how a battery is charged. So without wasting time, let's start. My previous video lectures are also uploaded of this solar power system training course. You can also visit them. Okay, so let's say that we have a battery which is rated as this is a 12 volts battery, and this is around 220 ampere hour battery. Okay, and this battery is it may be of any type, but it is one of the type belong to, this is actually the lead acid battery. Now either it is an AGM battery, or it is a tubular battery, or it is a VRLA battery, whatever the type it is, it belongs to the lead acid type of the battery. And in my previous video lectures, I have explained about the battery types. If you don't know, if you are unaware of that lecture video, or if you haven't seen that video lecture, then I will recommend you to first watch that video lecture and then move on to this video lecture. Okay, so let's say we have a 12 volts 220 ampere hour lead acid battery, and we have to charge it, or we are designing a battery charger for this type of battery. In this lecture, we are going to discuss few things like how much the charging current this battery required. So then by which technique your battery charger is going to charge this battery. Now battery charger is present along with the PV panel, or it is present along with your utility supply. So what is the first step? Now let's say here you have a battery charger. This is a battery charger, and it has to charge this battery. Okay, it has these two terminals, like one is the positive and another is connected to the negative. And this battery charger is taking supply either from your grid, or it may be powered up by some PV array. Okay, so it depends on how it is basically charging. Now battery charger, either it is a maximum power point tracking charger if it is charging the battery through PV array, or if it is a grid charging, or if it is charging from the grid. Well, whatever the mode it is. Now we are here going to understand the basic working of this battery charger. What is the phenomena? By what phenomenon it is actually your battery is charged, or what are the modes of a battery charger? Also in your homes you have UPS. Okay, the power backup for in case of power outages. Obviously it also has the battery charger in it. Now the first step is, in order to charge this 12 volts battery, how much voltage should the battery charger regulate across the battery terminals? The battery charger should regulate around up to maximum 14.6 volts can be maintained across this battery through this battery charger. Either it can apply 13 volts, or the voltage must be higher than the voltage rating of the battery. Normally battery chargers charge the battery around 14 volts or something, 13.8 volts to up to 14.6 volts are applied across the battery. Now this is what the voltage rating. But what about the current. How much current will flow out of this battery charger? Now here, one thing is very important. You have decided that you are going to charge the battery of 12 volt having the ampere hour rating of 220 ampere hour. Now, since it is, as I told you in my previous video lecture, in most of the batteries which are used for the PV backup, it is mentioned that at the rate of 20 hours, if it is mentioned. Normally, the batteries which are used for backup purposes, they have this rating mentioned on them. If this is the battery, then how much the maximum current this battery could draw from the battery charger? So that current, we can calculate that current by this formula, 220 ampere hour equal to ampere, and here we put 10, because we are now find out the charging current, not the discharging current, and 20 hours is mentioned for the discharging time. So this is 10 hours. So this battery will draw up to 220 amperes while charging. So one thing is for sure, that your battery charger must be able to provide almost 25 amperes. So the battery charger should be rated as 25 ampere. It should be able to provide 25 amperes to the battery. If you connect this battery to a battery charger, which can charge a battery, and the battery charger has the rating of, let's say the battery charger has the mentioned rating of 10 amperes, then this battery charger will trip up, because the battery will draw 25 amperes from this battery charger, and your battery charger is unable to provide 25 amperes. So that's why I am not taking the battery charger of 10 amperes rating. I am taking the battery charger which having the mentioned rating of 25 amperes, so that my battery is charged. Now what happens? Now there are three modes in operation when the battery, when you are charging the battery. Now what are those modes? There are three standard modes, and now it depends either the battery charger has those modes available to charge the battery or not. The first mode is known as the, so what are the modes during battery charging? Or you can say that we are going to study the battery charging stages. So the first stage is bulk charging. The second stage is absorption. This is absorption charging stage. For stage or state, you can say bulk charging stage. And the third one is trickle or float charging stage. This is very important lecture. If you are able to clear your concepts, for sure, 100% concepts clear guarantee. If you understand this lecture, you will able to clear your all the concepts which are involved. Either you are doing the programming of a battery charger, you are designing a battery charger, or you want to understand that how the battery is charged. This lecture is very important for you guys. And this is the real practical knowledge and not available in most of the textbooks. Okay, so there are three stages: the bulk charging stage, the absorption charging stage, and the number third is the trickle charging stage. Now look what happens. Let's say your battery at the start your battery is fully discharged. Okay, there is no charge stored in the battery. Whenever you will apply either 14.6 volts across this battery will start drawing the current. Now, how much current this battery, this lead acid battery will draw, it depends completely on the battery characteristic. And how much current it will draw, we just calculated. This battery will draw 22 amperes maximum value of the current when this is fully discharged. And when the battery is charged up to its 75% of 75% of charge, that is, this battery is around charged 75%, then what happens? The current drawn by the battery starts to decrease. Now, let's say when the battery is charged to around 75%, the current drawn by the battery decreases up to around 4 amperes. Now, this is the time your battery charger has to decide either it should cut off the battery charging stage or not. That stage is known as the absorption stage. Don't worry, I'm just opening up. I'm going to share my computer screen with you, and I'm going to share you the charging graph soon. So this is what known as the absorption stage. Okay, so understand. Now let me share with you the computer screen where we have a detailed graphical representation of the battery charging current. So here you see, now this is the graph which is telling you about the battery charging. Now look, at the start when, okay, let me show that, yes, my screen is shared. Okay, at the start, when the battery has no charge, okay, this is known as V discharged. Now what happens is that you applied 14.6 volts across the battery. Now battery is charging. Now this is the current I told you, the 22 amperes current, right? The 22 amperes current I just told you here that this battery will draw. Okay, so battery will start from here, and now the battery is charging. Now what happens, this is the voltage, this is the internal voltage buildup. This blue line of the voltage is what? This is the internal voltage buildup of the battery, and Vmax is what you are applying. Now Vmax is around 14.6 volts, which you are applying, and V float is the 12 volts. Or you can say, yes, the 12 volts, the floating voltage of the battery, at which the battery is on the steady state. Okay, and Vmax is what? The applied voltage. Clear one thing, Vmax is the applied voltage, V float is the voltage which is the voltage of the battery when it is under no charge state, that is, we are not charging the battery at that time. Now look, when we applied 14.6 volt, this is the current the battery will be drawing, and this is around 12 point. This is around 22 amperes. Now what happens? This is the bulk charging stage, and the battery is charging. Now what happens at this time instant is that, now let me draw this. Okay. Now at this point, the battery is around 75% charged. Okay, the battery is around 75% charged. Now what happens? The charging current, that is the current which battery is drawing, tends to decrease, and it was 22 ampere at that time, and the battery charger monitors this current. Now when this current reduces to a few percentage of the current, like let's say here the current is 4 amperes. Now what happens? The battery charger cuts off the charging current. Okay, Now, in some of the battery chargers, there are only two modes. Let me draw this on the board. Okay, let me draw here. You will see. So let me draw here with complete. In some of the battery chargers, there are two stages. Okay, we have the battery. As I told you, we have the, sorry, I have removed that. We have a battery which is 12 volt and 220 ampere hour battery rated at the rate of 20 hours. Okay, now this battery will draw 22 amperes when fully discharged, when it is in the fully discharged condition. Now I have a battery charger which is connected. Now this will be the graph. Okay, so the battery charger is providing you with 14.6 volts, and this is the 12 volt, which is the voltage of the battery under the steady state. Now what happens, and I'm merging these graphs, the current versus voltage. Now what happens, you applied this voltage on the battery, 14.6 volt. Now the current will start from, let's say the current will start from 22 amperes, and this is what, here we have the time. So when time, now 22 amperes current is drawn by the battery. Now there comes a point that this battery is around 75% charged. Now what happens, the current starts to decrease with time, and it will reach around the value of 4 amperes. Now this current depends on the battery characteristic. This current also depends on the battery characteristics. Now the current has reduced to 4 amperes. Now this is a very important thing. The battery charger should detect that now the 4 ampere current is drawn at a constant rate. So what happens? The battery charger must disconnect the charging. At this time, the charging must be disconnected. And when the charging is disconnected, at that time, the battery may achieve the 12 volts. Because, and what is the battery voltage now? The battery reaches this much. Sorry, let me use the black color. Now this is the battery voltage, the internal battery voltage. This is not the charging voltage. Now at the end of the bulk stage, this is the bulk charging stage. At the end of the bulk charging stage, how you detected that the bulk charging stage is ended? The current has started to decrease. It means that the battery is around 75% charged, and the battery voltage is now almost equal to the 14.6, which is the charging voltage. Now, now this is the battery voltage. As soon as you disconnect the charging, once the absorption stage is over, what happens? The battery voltage drops to 12 volt, which is the steady state condition. And now the charger has also disconnected. If your battery charger will not stop at this point, now the battery charger should disconnect the battery charging. The battery will be safe. If the battery charger is further continue to charge the battery, then what happens? The battery will damage. So at the end of the absorption stage, your battery is charged around 100%. Now, in cheap or in some of the battery chargers, there are only two stages of charging. One is bulk charging stage, and another one is absorption charging stage. Now, the third stage is the trickle charging stage. What happens? What the battery charger does, what after some time, now battery charger has stopped charging. After some time, it will allow it will start charging the battery again. and now this battery will again draw 4 amperes, because 4 amperes is the amount of the current which battery will draw, either it is fully charged or not. Remember one thing, that a fully charged battery, if it doesn't matter, if the battery is fully charged, it will draw the current if you will apply a voltage across it. It means that this is not the thing that that you just connect the voltage here across the battery and you will assume that the battery will charge. No, the battery will heat up and it will get damaged. So the battery charger does what? It protects the battery. When the battery is at the end of the absorption state, the battery charger disconnects the battery. But what is the trickle stage? The battery charger does what? It starts charging again, and obviously the battery is fully charged, so it means that it will draw 4 ampere current and it will disconnect again. In this way, what happens? This is known as the finishing stage. What happens is that the battery is perfectly charged up to the perfection. But what is the drawback of trickle charging stage? That if it is if this stage is working for a longer time and the battery is not used, then trickle charging stage may overcharge the battery. So an intelligent battery charger detects that this battery is not used for the long time. So that intelligent battery charger stops this trickle charging stage until and unless you are not using the battery on continuous basis. Understand? So we have 3 modes of battery charging, or there are 3 battery charging stages. Let me explain this stuff. Now look here. At the start, we started to charge the battery, and the battery draw the maximum current which it could draw. Now after some time, the charging current of the battery decreases itself. Okay, the current is decreasing, and it reaches this point that now now that your battery charger knows that this is the value of the current that which and at that the battery charging must be cut off. So at 4 amperes current, 4 amperes is for the typical case. Your battery may have some different value, so you actually adjust it manually, or what happens is that there is some time that this current continues and then it ends. Okay, sometimes somehow this graph is made. Now look, let me draw it. In some cases you have such type of graph, then it disconnects. Okay, now the battery charger understands that this is the 4 ampere current, or the value of the current which is the lower value and which is constant for some time. So at this time it disconnects the charging. So this is what known as the absorption stage or topping stage. And then you have finishing stage. That is, now if there is a trickle charging or float charging available, then what happens? After some time, again the battery charger will start charging the battery, and you can see the voltage dropped the floating value, and then it moved up and then drop. Now during trickle charging, what happens? The charging voltage is also dropped. Moreover, the charging current is also being controlled, or either it is controlled or not, but the voltage, this is what the applied voltage again, and and this is what the voltage of the battery. Okay, so understand there are 3 modes of charging everywhere. Universally there are 3 modes: the bulk charging mode, the absorption mode, and the float charging mode, or you can see this is the float charging stage. So I hope that your concepts about the battery charging are now clear. So I'm going to to end up this video session, and we will meet with another topic in our next video. Thanks.